Hey everybody, Jeff Oriyama here. What are PQs, and why do so many GraphQL people insist on using them? The answer is simpler than you think, but the terminology is more confusing than it should be. I'm going to tell you what PQs are, dive into the history of this practice, and then help you navigate today's ecosystem so that you can tell the difference between PQ, APQ, Safelisting, and trusted documents, and what that means for your platform's observability, performance, security, and developer experience. All of this has to do with identifying operations. An operation is a query, mutation, or subscription, and any of those can contain separately declared fragments. The section of the payload containing an operation and its fragments is referred to as a document in the GraphQL specification. The basic mechanism is fairly simple. A client has a GraphQL operation, including its name, variables, and selection set. If the server knows what that operation contains ahead of time, the client can do something pretty cool. Instead of sending that complete document with every request, it sends just an identifier. That identifier might be assigned by a server, although today it is commonly a cryptographic hash of the operation text. The server uses that identifier to retrieve the full document and then executes it with the supplied variables. This can reduce request size considerably. Some GraphQL operations are small enough that the savings barely matter, while operations generated by a compiler can become extremely large, so the savings are significant. It may also make HTTP caching easier, because the identifier can be included in a stable URL. The mechanism can support security as well, but only when the server controls which operations are stored and rejects everything else. More on that later. That last qualification is where most of the terminology starts to become important. When the server receives an identifier, it does not recognize how did the operation get into the registry in the first place, and what happens now that it is missing. Those questions are more useful than asking whether a product simply supports persisted queries. To understand why we have several answers, it helps to dig into the history. Let's go back to Facebook's original use of GraphQL. GraphQL had been running inside Facebook's native mobile applications since 2012. According to Meta's account of the system, the mobile teams were constructing queries by combining strings and then uploading the resulting documents over relatively slow connections. Some of those generated queries grew to tens of thousands of lines, and every installation of the same application was sending largely the same documents. The mobile teams eventually made those operations statically knowable. They could construct and optimize an operation during development, save it on Facebook's servers, and put a small identifier into the mobile application. At runtime, the application sent that identifier and its variables, and the server already knew which GraphQL document to execute. Relay Modern adopted a similar compiler-oriented approach when Facebook released it publicly around 2017. The environment surrounding that design is important. Facebook controlled the clients, controlled the GraphQL server, the compiler, and the deployment pipeline. If a build introduced a new operation, the pipeline could publish that operation to the server before clients attempted to execute it in production. The server did not need to learn arbitrary operations from prod traffic. This general idea appeared in Apollo's open source tooling in early 2017 with a project called Persisted GraphQL. It inspected a client codebase, extracted its operations, assigned identifiers, and generated a map that could be distributed to the client and server. Apollo's original explanation emphasized both smaller requests and query safe listing. If the server only loaded operations from that map, a caller could not invent a new GraphQL operation and execute it directly. That approach works well when you control the clients and can coordinate publication of the operation map. But when the client and server teams have separate deployment pipelines, several applications share one graph, or third-party developers can construct their own operations, complexity emerges. Every new client release may need to publish its operations before users receive it, and the server must retain operations used by older client versions. So these are all early examples of the pattern that is now referred to as persisted queries, or sometimes persisted operations. It's the idea that the client and server can refer to the same operation by a common identifier instead of its long form. Later in 2017, Apollo introduced automatic persisted queries to reduce that coordination. Automatic persisted queries, or APQ, begins with the client calculating a SHA-256 hash of an operation. The client sends the hash without the operation text. If the server recognizes it, the request proceeds normally. If the server does not recognize it, the server responds with a persisted query not found error, and the client retries with both the hash and the complete operation. The server verifies the hash, stores that mapping, and future requests can then send only the hash. So that word automatic refers to that exact registration process. There is no manifest that must arrive ahead of the client. The first request teaches the server about the operation, and the handshake also allows the system to recover if an entry disappears from the cache. That makes APQ useful as a bandwidth optimization. But the automatic registration behavior matters when evaluating it as, say, a security feature. If a client is allowed to submit complete operations after a cache miss, that client can introduce new operations into the cache. The server is remembering operations it has observed rather than enforcing a set that was approved in advance. So let's pause there. All right, so we have persisted queries, or PQs. We have automatic persisted queries, or APQs. I'd categorize these as a performance and observability feature. Being able to refer to an operation by an identifier that can be included in a URL param unlocks a new HTTP caching opportunity, and it also makes it easier to trace GraphQL operations via OpenTelemetry or other observability solutions. But there are other benefits to be had, as I mentioned earlier, when GraphQL servers know ahead of time which queries, mutations, and subscriptions it will be serving in production. Namely, Safelisting. It's the concept that if, like in the Facebook example, you control all the clients consuming your graph, you can keep a list of all the operations that they'll be executing in production and reject any that aren't on that list. This pattern is also referred to as trusted documents. You don't need to use persisted queries in order to build a safe list or trusted documents list, but the two patterns often go hand in hand. Persisted queries with Safelisting take the controlled publication approach. A build system extracts the operations used by trusted clients and publishes them to the server or an operation registry. At runtime, clients send their identifiers, and the server rejects identifiers that are absent from the published list. A cache miss is no longer an invitation for the client to supply a new document. It means that the operation is unavailable or unauthorized. This leaves us with three useful definitions. Persisted query describes the general mechanism in which the server stores a GraphQL document and the client sends an identifier. APQ adds a runtime handshake that allows previously unknown operations to register themselves. Safelisting, also called trusted documents, require operations to be published through an approved channel and reject anything outside that set. Unfortunately, persisted queries is also sometimes used specifically for the build time approach, so you cannot always determine the behavior from the feature name. So in whatever implementation you're working with, make sure you refer to the documentation, which needs to tell you how the registration occurs and whether the server accepts complete operation text in production. If your main concern is reducing request size and your clients truly cannot participate in a coordinated publication pipeline, APQ may be enough, though I would push back on any team before accepting this at face value. If you control your clients and want to limit them to reviewed operations, you probably want a manifest-based system with Safelisting enabled. You can also publish operations ahead of time without enforcing a safe list, but in that configuration, persistence should not be treated as an access control. The history helps explain why these features look so similar while making different trade-offs. Facebook's version grew out of a tightly controlled mobile build system. APQ adapted the mechanism for environments where that coordination was difficult. Safelisting and trusted documents preserve the controlled operation set when security and governance are part of the requirement. Whenever you encounter another persisted query feature, you need only ask two questions. 1. How does an operation enter the persisted set? And 2. What happens when the server receives an identifier it does not recognize? Once you have those answers, the name matters a little less. Hopefully that helps clarify the domain for you and your team. And if it did, don't forget to like the video. Are you using persisted queries in your platform? Do you maintain a safe list? Leave a comment and let us know. That's it for now. See you next time.